Okay, so here are the guided notes that I'm going to try to provide you today. Today we're looking at circles and arcs. There are some basic stuff that we probably already know, which is radius, diameter, and circumference. So I'm going to go ahead and draw each of those for you really quick. We obviously, radius is the center of our circle. The radius comes out, of course, from the center straight out to the point on the circle. This is the radius, no big deal. And then, of course, if you go all the way across, then we have the diameter. And again, we should kind of already know this. This has been introduced a long time ago. And then, so the whole thing is the diameter, of course. And then the circumference is just basically the distance around the circle. So the circumference is just basically, the formula for circumference, by the way, is basically the length of our diameter times pi. But the radius basically is the distance from, again, that distance from the center to the point on the circle, anywhere on the circle. Of course, all the radii, plural for radius, are all the same length. No big deal, right? Okay, so just wanted to make sure that was straight. So then now, the next thing is the central angle. What is a central angle? It's just any angle whose vertex is at the center. Okay, so the vertex is the center. Okay, so it's just any angle. Okay, the vertex is in the center, or is the center. Okay, so if I just take another radius as an example and just go ahead and draw it straight out, then now we have an angle. We have this angle right here. And by the way, I've drawn it the way it looks. It's going to be a right angle. So you have, here is our central angle. And we'll call this angle, we'll call the center C, I guess. So that point is C. We'll call this A, and go figure, we'll call that B. Okay, so now we have the central angle ACB, or BCA. Remember how to name angles, right? It doesn't matter as long as your vertex is correct. Okay, so we're looking at angle ACB. So that's your central angle. So I'll put on here angle ACB. That's the central angle in our example right here. Okay, and also notice that we have another central angle right here. We can call this, we'll call this point D. Doesn't matter. So now, if you also notice that we have a central angle here, and it's also 90 degrees, right? And we have another central angle, which is this large angle right here, right? That's an angle. It's a straight angle. Remember, its measure is 180 degrees. So there's another central angle. We don't think of straight angles a lot of times as an angle, but it is. So there are your three central angles that I've drawn by just drawing two radii there. Okay, or actually three. So, but that's what a central angle is. Its vertex is at the center. So then now, once we draw this angle, then now we've created several other things. But what we're focused on today are arcs. An arc is just part of a circle. So here we have arc AB. Right there. Here, from here to here, we have arc BD. Like a segment is part of a line, an arc is part of a circle. So we just use the next, the two letters to name where we start and where we finish. Arc BD. If I say arc BA, arc B to arc A. The order of the letters does matter. It doesn't matter if you're looking at just say two letters, but if it does, if you say three letters. So, so first of all, let me write down the definition. An arc is just part of a circle. So, arc is just part of a circle. Now, what we have here is we have... well, let's go ahead and draw one more radius here. We'll go ahead and draw it right here. And actually, we'll draw it right here. So, oh, I messed up the letter. So, we'll draw an arc right here. We'll go ahead and label this E, just to take turns here, A, B, C, D, E. And so now, again, we have another central angle, ACE, and notice that C is the vertex. It's in the center of the circle, so it's a central angle. So now we have an arc, EA, arc AB, arc BD, and all three of these examples are what we call minor arcs. Minor arcs, sorry, I've got to get that straightened up here. All of these, from E to A to B, B to D, they're all minor arcs. And the reason why they're minor is that all of their measurements, okay, it's just an arc with a measurement less than 180 degrees, less than half. That's less than 180. This is less than 180. This is less than 180. And how do I know what the measurement is? We'll get to that in a second. Okay? A major arc would be an arc whose measurement is actually greater than it's an arc with a measurement that's greater than 180. And a semicircle, which we know is a half circle, so it's going to be an arc with a measurement that equals exactly 180, which is half the circle. That right there is a semicircle. Right here, that's a semicircle. Okay, so how do we find the measurements of an arc? That's really, really easy because of one simple equation. Whatever the central angle measurement is, the arc measurement is also the same. So, central angles equal arc measure. They are exactly the same. One and the same. So, the angle measurement here of this central angle is 90 degrees, so the arc measure is also 90 degrees. So the arc measurement of AB is 90 degrees. The arc measurement of BD is also 90 degrees. If I tell you that the arc measure from E to A is 40 degrees, then the angle measurement ECA is also then going to be 40 degrees. They're one and the same. Because it's a central angle, it equals the arc measurement. And if it's the arc measurement, then if it's a central angle, it has the same measurement. They are exactly the same. Central angles equal arc measure. So 40, 40, 90, 90, 90, 90. So if I tell you that the angle of AD, which is a straight angle, is 180 degrees, then the arc measure of ABD is also 180. Notice how I named that. ABD. Okay? You could also say DBA, but the order matters. You have to stay on the circle and you can't go in reverse. Okay? You can't decide to go A, B, and then come around and then call it D. No, that's different. Once you start in one direction, you keep going the same direction. So A, B, and keep going that direction, D. Okay? So, now, hopefully this is all clear. Hopefully this is getting the basics across to you today. But just wanted to make sure that we know the relationship between central angles and arc measure. This is the most important thing that you can learn right here. Central angles equal arc measure. So if I were to simply ask you the question, what is the measurement of, and we'll do this one example here, what would be the measurement of, and this is the symbol for arc. It looks just like an arc. Okay, so what is the measurement of arc EBD? Arc EBD. So the measurement of that arc, you will start with E, go to B, and you go directly to B. You always take the shortest path from E to B. You don't go E to B. You don't do that, okay? You got to go to the straightest, fastest, not the straightest, maybe that's the wrong word, but you go to the shortest route from E to B. So the shortest route would be here. So you go E clockwise. So E to B, and then from B down here to D. So E, B, D. Okay? And you simply add up all those numbers. So that's 40 and that's 180. So for a grand total of 220 degrees. 40 and 180 will give you that arc measurement, EBD. E to B all the way to D. 220 degrees. So that's arc addition, just like segment addition or angle addition that we learned a long, long time ago. So I hope that this will get you off to a good start as far as Tuesday and the rest of the assignments. Again, count on another video coming tomorrow that will do more examples and solving. And hopefully we'll all be in a very good place. I hope you guys are all staying well again, and I look forward to seeing you guys in the future. Okay, so hopefully this helps. If you have any questions, email me, and I will do the very best I can to help you out. All right, have a great day.